Hello dear students, welcome to My Science Academy. Today we are going to discuss 11th Physics chapter first, Physical World. Before starting Physical World, we have to know about science. So what is science? Science is a systemized and organized knowledge about various natural phenomena which is obtained by careful experimentation, keen observation and accurate reasoning. And this lecture will be very helpful for rbse and CBSE English medium students. So we are talking about science. Science referred by a Sanskrit word shastra and Arabic word ilm also have a similar meaning, organized knowledge. So our definition, systemized and organized knowledge. And science came from Latin word scientia, which means no. There are two types of science: physical and biological sciences. Biological science which deals with behavior of living things, called biological science. These science include botany, zoology, ornithology, anthropology, entomology, and forensic science. These are branches of biological science. Second, physical science. And physical science, two men study physics and chemistry. Chemistry is the study of every substance, its structure, its composition and changes. Which is the take place. Physics is a study of natural world which deals with the concept of space, time, motion, matter and energy and radiation, etc. And branches of physical science: geology, geology, geography, astronomy, astrology, and oceanology, etc. So here is the first term in our NCERT book, scientific attitude. What is a scientific attitude? So we know tremendous growth of science has been taken place only due to use of scientific attitude and scientific method. So scientific attitude require a flexible, open-minded approach towards solving problems in which other important points of view are not neglected without any reason. In a scientific attitude, first we take a solution. It is suggested for a problem. Then this solution is tried. If it works satisfactory, it is adopted. Otherwise, it is replaced by a better solution to the same problem. Next terminology is scientific method. The step-by-step approach used by scientists in studying natural phenomena and stabilizing laws which govern these phenomena is called scientific method. Generally, we involve following step in any scientific method. First, taking a large number of systematic observation. In scientific method, there is a large number of systematic observation by doing controlled experiments. Second, studying these observation and making qualitative and quantitative reasoning. Third, suggesting mathematical models. Third step, mathematical models to account for observed behavior. And fourth step, predicting new phenomena on the basis of suggested model. And fifth, modifying the theory if necessary in the light of fresh evidence. These are steps for a scientific method. Next, scientific theory. What is a scientific theory? Theory is a name given to a set of limited number of laws. In very easy way, set of limited number of laws in terms of which the behavior of a physical system can be explained. And what is the need for modification of a scientific theory? These are key points. In science, no theory is final. A theory must be able to explain what may be observed from time to time. So there may be two problems. First, a new observation shows some deviation from existing theory. There will be some deviation from existing theory. And second, modification of a theory fails to account for the new observations. For example, first, new observation shows some deviation from existing theory. For example, Kepler examined the extensive data on planetary motion collected by Tycho Brahe and the planetary circular orbit in heliocentric theory. Sun heliocentric theory say Sun at the center of solar system imagined by Nicholas Copernicus had to be replaced by elliptical orbits to fit the data better. These theories need for modification. And second, modification of a theory fails to account for new observation. When new observation occurs, we have to need for modification these theories. Like a Newtonian mechanics could not explain some basic features of atomic phenomena. And wave theory of light failed to explain photoelectric effect. These will discuss in class 12, wave theory. And these result in development of entirely new theory called quantum mechanics. Next, interplay between theoretical models and experiments. Sometimes a new experiment suggests an alternative theoretical model. Second, sometimes a theoretical advancement predicts a new experiment. Next topic, two basic questions in physics. First, unification, and second, reductionism. In physics, atom is made to explain various physical phenomena in terms of just few concept and laws. Because we are trying to see physical world as a manifestation of some universal laws. For example, Newton's law of gravitation can be used to describe the motion of a body falling toward the earth, motion of the moon around the earth, and motion of the planets around the sun. Reductionism. Reductionism means minimization, lowerization. This is attempt made in physics to explain my macroscopic macroscopic system in terms of its microscopic constituents. For example, thermodynamics was developed to explain macroscopic properties such as temperature, internal energy, entropy, etc. And later on, we were explained in terms of molecules in KTZ, kinetic theory of cases in statistical mechanics. Next, scope of physics. The scope of physics is very wide. Next branch of physics. Physics have two domains of study: macroscopic and microscopic. In macroscopic and microscopic physics divided in two parts: classical physics and modern physics. या फिर otherwise we can say classical physics or quantum physics, either classical mechanics, quantum mechanics. In classical physics deals with the macroscopic phenomena which may be at laboratory, terrestrial, and astronomical scales. Like astronomical scale, like planets, like Earth, natural satellites like moon, sun, stars, etc. And quantum physics, quantum mechanics deals with the microscopic phenomena at the minute scale of atoms, molecules, and nuclei. Main sub division in physics and these branches: mechanics, nuclear physics, optics, electromagnetic, solid state, electrodynamics. So first branch, mechanics, it deals with the equilibrium or motion of material bodies at low speeds. For example, propulsion of rocket, equilibrium, road bend under a load, propagation of water waves or sound waves in air. Second, optics, it deals with the nature and propagation of light, which deals with the formation of image by mirrors and lenses, colors in thin films. Next branch, thermodynamics, it deals with the macroscopic system and equilibrium and is concerned with the changes in internal energy, temperature, entropy. Fourth branch, electrodynamics, it deals with the electric and magnetic phenomena associated with charge and magnetic bodies. For example, electrodynamics laws given by Coulomb Oersted, Ampere, and Faraday. And later on, electrodynamics laws defined by Maxwell. It's deal with like motion of current carrying conductor in magnetic field. Next branch, relativity. It is theory of invariance in nature. It deal with the motion of particles having speeds comparable to speed of light. These are sub branches of physics. Excitement of physics. Physics has a wide range and complexity of physical phenomena. People get excitement in carrying out new challenging experiment to unfold the mysteries of nature. In physics, we will study here fundamental forces in nature. So, fundamental forces are divided macroscopic world. We observe several kind of forces like muscular force, contact force, friction force, force exerted by spring, viscous force, electric force, magnetic force, and these all forces between macroscopic objects arise from two fundamental forces, gravitational force and electromagnetic force. So let's continue with gravitational force, and here is a comparison between these forces, how much strong and weaker they are. Fg for gravitational force, Fc weak force, Fe electromagnetic force, Fs strong nuclear force, 1 10 to the power 25, 10 to the power 36, and 10 to the power 38. So you can see here which is strong, which is weaker. So gravitational force, it is the force of mutual attraction between two bodies by virtue of their masses. So law of gravitation attraction between two bodies of masses m1 and m2 separated by distance r. So these forces given by F equal to Z m1 dot m2 upon me r, and G is a gravitational constant which value is 6.67 in 10 to the power minus 6.67 into 10 to the power minus 11 Newton into meter square upon me C square. Next, some properties of gravitational force. It is a universal attractive force, which means two bodies of masses will attract each other. So it is the nature of these forces attractive, and it is directly proportional to product of the masses of two bodies m1 and m2, and it is proportional to 1 upon r. and r is distance between two mass particle. For example, we can write here m1 and m2. Distance r. It obeys inverse square law, and it is the weakest force known in nature. In last slide, we take a ratio of 4 forces. It is a conservative force. It is a long range force. It does not need any medium for its operation, and it is the weakest force in nature. It is the center force because it acts along the line joining the center of two bodies. Next, electromagnetic force. The force acting between two electric charges at rest is called electrostatic force. According to Coulomb's law, magnitude of electrostatic force F between 2-point charges Q1 and Q2 separated by distance r in vacuum is given by F equal to 1 upon 4 pi epsilon naught Q1 dot Q2 upon में r square, where epsilon naught is permittivity of vacuum. So force acting between two magnetic poles is called magnetic force. And properties of electromagnetic force may be attractive or repulsive. It obeys inverse square law. It is the center force and it is a conservative force. Next, electromagnetic nature of some macroscopic forces. For example, first, contact force between two bodies. When two bodies in contact with each other, their atoms come closer to each other at the surface of contact. Next, force of friction. Force of friction. Sometimes electromagnetic contact force between two bodies may have a component parallel to surface of contact. This component is called friction. Third, elastic force in spring, van der Waals force, and fifth, force in taut spring or rope. These are example of electromagnetic nature of macroscopic forces. Next, strong nuclear force. The strong attractive force which binds together the proton and neutrons in a nucleus called strong nuclear force. And this type of force is 10 power 38 times stronger than gravitational force, and it is a short range force because it operates only over a size of nucleus 10 to the power minus 15, and it is a non-central and non-conservative force. Last for weak nuclear force, it is the force that appears only between elementary particles involved in a nuclear process such as a beta decay of a nucleus. So neutrino and antineutrino is governed by weak nuclear forces, and it is 10 to the power 25 times stronger than gravitational force, and it operates in range of nuclear size 10 to the power minus 15. Next, there are some laws, conservation laws. law of conservation of energy, law of conservation of linear momentum, law of conservation of angular momentum, and law of conservation of charge. And we will discuss in these conservation laws in class 11th, and some, for example, law of conservation of charge in class 12th, chapter 1st. So law of conservation of energy cannot be generated or energy cannot be destroyed. So energy is converted in all bodies. It can be transferred from one body to another body. Thanks for watching the video.